Today I'm coming to you with a few updates. There's a lot happening here. First of all, the main topic. Let's get this out of the way. I put in some ultra bright LEDs and I will first surprise you with the brightness. Let's turn this on. We will have to see how this is in the video. The thing with these LEDs is they are not that hot, but they still have metal heat sinks. And I've tried turning them on for a while and there was nothing overheating yet. I cannot say anything about the efficiency, but they seem to work. Next big upgrade I've made, I put all the electronics in 3D printed box. And this is why I had also to relocate the on-off switch. This is just for now. I put the switch back here. I will have to cut or melt out a hole for the switch, but right now it's fine that way. So let me open up the car and show you the internals. So these are the internals. First I will show you the LEDs. It's these right here, and here you can see the heat sinks, and I'll try not to look directly at it because they are really terribly bright, but here you go. I'm not looking directly. I hope you can see it, but they are really terribly bright. And well, I got more than I wanted. I just wanted some bright LEDs. I asked a friend that does a lot of things with LEDs in his PhD, and he just had these lying around, and I thought to myself, well, bright is good, I hope, I guess. And I got more than I wanted. But it's actually funny, when you drive in the dark, the whole room is lit. Next thing, this box here, it's mounted with a twist tie. I know it's not beautiful, but it works. But on the back, it's also mounted by a single M2 bolt and nut. So let's show what's inside here, because I also had to make some changes. If you open up this box here, it's just 3D printed PLA. You see a whole lot of stuffed electronics in there, and I'll show you the main components that are important for these LED. It's this one right here. This is actually necessary because otherwise these will just burn out. They can get past 100 degrees and just melt the PLA and the plastic. These limit the current, I think. I'm not that good with these two. They limit the current to 700 milliamps, but not below 700 milliamps. It would always be exactly 700 milliamps. I only know the German name. It's KSQ or Konstantstromquelle. But you might know what I'm talking about. So just close this up. Maybe I'll make another mounting system here in the front on the board for the box, but right now the twist tie will do. So next I wanted to answer some questions that I got in the subreddit. First of all, what are these Lego parts for? The problem with this thing is the gearbox, you can see it here, sticks out quite a lot. And it's not only sticking out, but it's sticking out past the mounting points for the lower links. And it has a very sharp and aggressive corner. What I make, because I can print stuff with my 3D printer, but I cannot model right now. There was no model for the specific thing I needed. So my solution was, well, I have a boatload of Legos, and I found out that these spacings are nearly, you can see a bit of bending here, but they are nearly exactly the same distance as Legos would be. So I made a sled that the ground can slide on the sled here and not hit the gearbox, which worked fine. Now it can climb stuff with a flat belly, which it couldn't do beforehand. So next question people ask was, how did I get the drive smooth? Because with the WPLs, everyone was complaining about binding. Yes, I had quite a lot of binding, and it's always there. What I did was limit the movement a bit. Here in the back you can see the drive shaft never goes past a ridiculous angle. And in the front I also limited the angle that it always has a bit of give. And yeah, a boatload of grease, I guess. And there's still a bit of binding going on, but it's not stopping the fun. It's just, it doesn't sound good. When you turn hard left, I'll try to demonstrate it here. When you turn hard and try to drive fast, you get, I don't know if you can hear it, but there's this whoop, 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 whoop. I didn't find a solution for that yet, but it's all right. It's all right with me, I guess. But if anyone has a suggestion what you can do, you can write it in the comments. What I already tried was limiting the angle. It's not sharper than the U-joints can handle. It actually should work, but it doesn't really. If you turn hard and drive in reverse, I've also noticed that the wheels turn sharper than when driving forward. Let's try to demonstrate that. So this would be forward. I turn as hard as I can. And when I drive backwards, the wheel turns even harder. This is forward. This is backward. It turns even harder. Some of you might have noticed that there is misfire going on. And I have my suspicions because this only happens in my room and nowhere else. Outside it all goes brilliantly, so I think there is too much noise in this room, and so this is why the control misfires. Sometimes when I leave it on, the car just drives on its own and has problem reversing and driving slowly. So I think it's just signal noise in this room. If you have any more questions, write them in the comments and I will try to tell you all about my upgrades. Lastly, I will just show a small view on my internals, and if you have questions about anything, how I got it, how I built it, just write it in the comments. So, thanks and bye-bye.